All right, Advanced Algebra Quadratics Unit Test Review. I realized later that I didn't even put the title on this. This is our quadratics that we're doing. Graph the function. Use the characteristics of the form to create your graph. This is in vertex form. So what I know right out of the gate is that the vertex is at 1, negative 3. Remember, vertex form is a times the quantity x minus h squared plus k. The vertex is sitting at 1, negative 3. My line of symmetry would be there. I'm interested in graphing at least one other point so I can find its corresponding point. And we can do this a multitude of ways. I want to show you just taking this vertex form and turning it into standard form, because the C value in standard form is the Y-intercept, and I want to get that. I'm going to multiply my quantity x minus 1 squared, turn it into x squared minus 2x plus 1. Notice I have to take the opposite of everything inside and still subtract 3. So in standard form, this quadratic is negative x squared plus 2x minus 4. That puts my y-intercept at negative 4. I'm going to put that on my graph, come across the axis of symmetry, and I've got my points to plot. You could have found different points on the graph. Make sure that you have evidence in place. Number 2, this is in standard form. In standard form, the vertex has an x value of negative b over 2a. So the x value of the vertex in this equation is going to be 12 over 2 times 3, which is 12 divided by 6, or 2. I'm going to go evaluate this function when x is 2 to find out the y value of the vertex. And when I go and put that into my calculator, I'm finding that the y value of the vertex is 40. Why does that seem weird? I don't feel like this vertex should be at 40. Because this is negative 2. There we go. Boom. Boom. That changes everything. Minus 24 plus 4. There we go. This vertex should be at negative 2, negative 8. Let me just check my math real quick here again, because I just screwed that right up. 12 minus 24 plus 4. Yeah, it is at negative 8. So my vertex is at... See, now I thought that, I caught my mistake because I'm like, wait a minute, why is that vertex so weird? I know the next graph I told you to do something different with because it was so difficult to graph. You won't run into that issue on your test. I'm going to put my vertex down here, negative 2, negative 8. And actually, I like standard form because I've got a y-intercept of 4. Come across, there's another point. Cool. I'm going to go on to problem 3. I'll probably break this video up into segments. Now, the graph of this turned out being obnoxious, so I'd ask you to do a few different things on this problem as opposed to graphing it. The first thing that I wanted you to tell me was the x-intercepts. This is in intercepts or factored form. That's y equals the quantity x minus p times the quantity x minus q. And the intercepts, or the zeros, are going to be sitting at your p and your q spots. So in this case, my x-intercepts are going to be 2 and negative 7. I'd ask you to also find the vertex. In order to find the vertex, a couple of ways we can go about this. I'd like to see you multiplying the binomials x minus 2 and x plus 7 together to put it into standard form. Negative 2x, 7x minus 14, x squared plus 5x minus 14. The vertex is going to be at negative 5 over 2. Negative 2.5 is the x value. And when I evaluate this function for 2.5, if I put it in, negative 2.5 squared plus 5 times negative 2.5 minus 14 is going to give me a negative 9. Something's not right with, I see exactly. My calculator doesn't have the value. I moved my decimal. There we go. Negative 20 1/4. So the vertex sits at negative 2.5, comma, negative 20 1/4. The other piece that I believe I asked you for was also the Y-intercept, which I know now from my vertex form is sitting at negative 14. I'll come back and start number 4 and 5 in another video.